chemical reactions and equations. Okay, this is our lesson. So red color is not visible for you, so I will take white color. So chemical reactions and equations. So in 10th class, CBSE board exams, chemistry part they will give 25 marks in the board exams. So chemistry is a crucial and easy subject also. So let's get into the class. Chemical reactions. Generally, in our day-to-day life, we are observing some situations, some changes. So let us see this. What are the changes have happened? Already you studied in the 7th class, physical changes and chemical changes. Physical changes and chemical changes. So just you can see, I will tell some situations, some changes. Generally, if your milk is there, what is that? Milk. This milk, when you left at room temperature, in which season? Summer season. Left at which temperature, ma? Room temperature. Room temperature. Which season? Summer season. Summer season. So what do you observe that time? The milk is converting to spoil, or some changes happen. So it is getting like sour. What happens? It is getting sour. So here what happens? So completely the milk is spoiled. Milk is spoiled. So okay. So at the same time, iron tawa. Which one? Iron tawa, or any iron articles, the iron nail. So if we are throw outside, so at least 1 day, 2 days, or 3 days, what you can observe? Some brown color coating will form. If you leave 2 or 3 days, you left, means what happens? The brown color layer formed on surface of the nail. Surface of the nail. So this is simply we can call as a rust. What we call? That is a rust. Why rust is formed? The iron nail is exposed on the humid atmosphere. Humid means the atmosphere containing moisture. That is called a humid atmosphere. So the iron is reacting with moisture to form a iron oxide. So this is called as a rusting. So we will discuss end of the lesson about rusting and corrosion also. So okay. Next, fermentation of grapes. What is that? Fermentation of grapes. So generally, grapes containing, which is present in grapes? Glucose is there. In grapes, which is present? Glucose. Large content glucose only. So this glucose is, after fermentation of these grapes, the glucose is converting to alcohol. Glucose is converting to alcohol. Actually, so large scale in industries they are preparing this alcohol by using the fermentation process. Fermentation process. So at the same time, generally we are taking food. What we are taking? Food. If we have survival on earth, we should take food. So after this food is converting to energy. Food is converting to energy. How it is possible? Again, we can get this food? No. So many reactions are taking place. So the food is converting to energy. Food is converting to energy. So okay, food is nothing but here you can take rice. So if you eat rice, finally you are getting energy or not? You are getting energy. In all the cases, so milk left at room temperature, summertime what happens? The milk will spoil. At the same time, iron nail kept outside, so it is exposed to humid atmosphere. What happens? A rust will form. The brown color layer will form. That is called as a rust. At the same time, fermentation of grapes. So not only grapes, you can take any fruit. It will get fermented by using fermentation process. We can prepare the alcohol in an industrial. So next, so generally we are taking food. So whatever we can take, any food you can take, so finally that is converting to glucose. So means in the form of energy. Glucose after that it is converting to energy. So in all the cases, we never get back the initial products, initial materials, or initial substances. So when milk is spoiled, can we get back the same milk? No. At the same time, iron is converting to brown color layer. Again, can we get back? No. Fermentation of grapes, even we can't get back the same as it is grape. So that's why these all processes are which process? These all processes are reversible or not. If we can't get back, no. So that's why we can call it as a irreversible. They are irreversible. Already studied in 7th class. All chemical changes are irreversible. As in chemical generally, chemical changes are irreversible. So we can't reverse them. So okay, now we can see some activities in the class 10 textbook. You can observe the activities. So in these activities, we will discuss what they are giving. So based on the activities, we can understand some important concepts. So activity 1.1. What is that? Activity 1.1. So you should keep your textbook when you are watching this video. You can keep your textbook in front of you. So in this activity 1.1, what they given? So he said, clean magnesium ribbon about 2 centimeters long, rubbed with sandpaper. Here we have to take which ribbon? Magnesium ribbon. We are taking magnesium ribbon in this act. So what he is saying? This rubbed with this and magnesium ribbon is rubbed with sandpaper. Rubbed with sandpaper. Here question is why we are rubbed with sandpaper. Why? Here only I am writing. So he said take magnesium ribbon. Then he said rubbed with sandpaper. Here my question is why? Why we are rubbing the surface of the magnesium ribbon Why we are rubbing with sandpaper? The reason is generally metals generally metals are reacting with oxygen. Reacting with oxygen, they can form metal oxides. They can form metal oxides. So metals, all metals are their reactivity not same. Already learned in the 8th class. Oh, so same thing we can discuss in 10th class also. So generally metals are reacting with oxygen. Metal oxide will form. So it is a thin layer. It is a thin layer. So this metal oxide thin layer. That is why so thin layer will form. So further it does not oxidized. So metals can react with oxygen. That is oxidation process. This process is what? Oxidation. Once it is oxidized, further it does not oxidize. Because of that reason, we are rubbing with sandpaper when doing this activity. Before that, we can rubbing with sandpaper on the surface of the magnesium ribbon. Why? We can remove this magnesium oxide layer. So for example, you can take this magnesium. It is reacting with oxygen to forms magnesium oxide. It is a thin layer. It is a thin layer. When we are rubbing with sandpaper, it will remove. It will remove. I am not balancing this equation. Just leave it. It's okay. This is the reason. So in exam point of view also they will ask why we are rubbing with sandpaper on the surface of the magnesium ribbon before burning. The reason is, what is the reason? So generally metals are magnesium ribbon is oxidized to form magnesium oxide layer on surface of the magnesium ribbon. So it is already oxidized. Further oxidation is not possible. Because of the reason, we can rubbing on the surface of the magnesium ribbon. So this is the thing. So then what we can do next, this whatever we are rubbing with sandpaper, then this magnesium ribbon burning when it is burning takes place without simply it will burn? No. In the presence of oxygen only it can burn. In the presence of oxygen only it can burn. So we can get to this magnesium oxide. What is this? Magnesium oxide. It is a white color powder. White color powder. So what the MgO means to some people are simply confusing. MgO means here magnesium oxide. What is this? Magnesium oxide. Magnesium oxide. So this is about activity 1. Activity 1 1.1. 1.1. So okay. So next, so when you have next one, activity 1 point you can see, just to keep in our mind. So what magnesium is burning. So magnesium here is solid. Here oxygen to find finally we are getting this white color powder. So that is magnesium oxide. So next activity 1.2. Activity 1.2. Activity 1.2. In this activity, what they given? 2 solutions they give. What are these? 2 solutions. What are these 2 solutions? They given lead nitrate. Two solutions they given. Clearly they mentioned two solutions. Which solutions these are? Aqueous solutions. What is this? Aqueous solutions they given. Aqueous solutions. The first solution is lead PbNO3 taken twice. This is called as lead nitrate. Lead nitrate solution. And the second one is Ki. It's a chemical name is potassium iodide. Potassium iodide. So just we are mixing these two solutions taken in a single test tube. So that means we can mix the two solutions in the test tube. So let what happens we can see. So lead nitrate. So it is an aqueous solution. Then potassium iodide. It is also aqueous solution. Finally, we are getting this lead iodide. Lead iodide and potassium nitrate will form. Which one? Potassium nitrate. KNO3. Potassium nitrate. Here, the lead iodide is a solid substance. Simply we can call it as a precipitate. We will discuss about the precipitate also. So precipitate means what is the precipitate? The substance which is formed in the chemical reaction and does not dissolve in water, that is called as a precipitate. So the substance which is formed in the chemical reaction. So here lead iodide is formed in the chemical reaction, but it does not dissolve in the water. So that type of substance is called as a precipitate. It is called as a precipitate. So okay. So just keep in your mind this activity 1.2 also. Activity 1.2 also. Just you can see here aqueous, here solid. Here this potassium nitrate also aqueous. So next, so in this activity also we cannot get back this potassium lead nitrate and potassium iodide. So why? Because here new product or new substance is formed. So next we will discuss activity 1.3. Activity 1.3. Activity 1.3. Activity 1.3. Activity 1.3. So in this activity 1.3, he also said take a few zinc granules. What is it? Take a, which one you can said? Zinc granules you can take. Zinc granules. Take some zinc granules in a conical flask. So conical flask means it is like a conical flask. In that what he said, you can take some zinc granules. Zinc granules. Then add dilute hydrochloric acid or sulfuric acid. So then he said you can add which one? H2SO4 sulfuric acid or HCl, any one you can add. After you can observe what happens in the inside of the conical flask. Just if you are observing this, so we are taking zinc granules as well as sulfuric acid or HCl. Sulfuric acid or HCl. So, is zinc granules can react with sulfuric acid or hydrochloric acid. So, we can observe here some bubbles are coming from the zinc granules. What we are observing here? Some bubbles coming from the coming from the surface of zinc granules. Surface of zinc granules. So what are these bubbles? These bubbles contains hydrogen gas. This bubble contains hydrogen gas. Actually, you studied in 8th class, metals and non-metals chapter. Metals reaction with acids. So you can already studied in the chemical properties of metals. So in that, metal reactivity of metals with dilute acids. So same here. So here zinc granules is reacting with, I am taking here HCl. Zinc granules. Here zinc is a solid and HCl means that is aqueous. Zinc granules is reacting with hydrochloric acid to form zinc chloride. This zinc chloride is aqueous and zinc chloride is aqueous and which gas is liberated? Hydrogen gas is liberated. So okay, hydrogen gas is liberated. So here we can check how we can check the hydrogen gas. Just take a burning paper or any burning matchstick or burning paper. You can keep on the mouth of the beaker or conical flask. It is burned with pop-up sound. How we can confirm hydrogen gas means it is burned with pop-up sound. Burn with which sound? Hydrogen gas present means it is burned with pop-up sound. Is burning with pop-up sound. Is that clear? Do you have any doubt here? So understood activity 1.3. We are here observing gases are liberated and next precipitate is formed before that reaction. It's okay. So in these three activities, what do you observe? We have to observe in these three activities some points we can observe here. Some points. What are that points? Which points we have to observe in these three activities? It's okay. So just you can see the first one is change in state. What you observed in this? First one is change in state. Here state means what? Physical state. Change in state. And what are the physical states already learned? Solid, liquid, gas. These are the physical states. So we are in these three activities, we observed one thing, change in the state. And change in color. Change in color. Second activity, yellow color lead iodide is formed. I forgot that. Change in color. Second activity, which is formed here, the precipitate is formed, that is yellow color precipitate. Yellow color precipitate, that name is lead iodide. Then evaluation of gas observed. Third activity, zinc granules, already we discussed, no? So in that evaluation of gas, what is that gas? Hydrogen gas. So hydrogen gas, oxygen gas, anything gas. But activity 1.3 we observed hydrogen gas is liberated in the given chemical reaction. So next, change in temperature. Change in temperature. So we will discuss in the coming topics. Change in temperature means some chemical reactions simply they can't start. If you are giving energy, it will start. Otherwise, it does not start. So, okay, for example, photosynthesis reaction without sunlight, it does not start. For example, we are respiration process. We are inhaling the oxygen, exhaling the carbon dioxide. Along with the carbon dioxide, some amount of heat also released. So, okay. So based on that, this change in temperature means two type of reactions are there: exothermic reactions and endothermic reactions. We will discuss what are these. Exothermic reactions and endothermic reactions. So in coming classes, I will explain very clearly. Two types of reactions you should keep in your mind. So, okay. So these changes are observed in the above three activities. So then we can conclude. So any chemical reaction takes place means we can observe these four changes. What are the four changes? Change in physical state, change in color, evolution of gas, or change in temperature. Any one of these, if you can observe, you can conclude that is a chemical reaction. That is a chemical reaction. In that, no doubt at all. Okay. So next we are going to discuss next topic, that is chemical equations. What is that? Chemical equations. Chemical equations. Okay. So from this activity 1.1, from activity 1.1. So what we discussed in the activity 1.1? Magnesium ribbon is burnt in air. What is it? Magnesium ribbon burnt in air. What happens in that? It is converting to magnesium oxide. Converting to magnesium oxide. So if you are writing this, simply how can your statement? When magnesium ribbon is burnt in oxygen, it is converted to magnesium oxide. This is called as a, okay, it indicates that sentence form is the chemical reaction. But if you are using the sentences, the books can occupy more space. So understanding also some a little difficult. So because of the sentence form is converting to word equation. Sentence form is converted to word equation. So now I am writing. First, you can see sentence form. Question. Sentence form. What is that? When magnesium ribbon is burnt in oxygen is burnt in oxygen is burnt in oxygen. It gets converted into converted into or converted to magnesium oxide. What is this? Magnesium oxide. See how much lengthy this equation or this statement is lengthy. The statement is very lengthy. We can't write all chemical reactions in statement form. It's very difficult. So then next we can convert it into word equation. So in this word equation, just we can write what substances are involved in the chemical reaction and what substances are formed in the chemical reaction. So in these, which are involved in the chemical reaction, those are called reactants. So let us see. So here, which is a magnesium ribbon. Magnesium means magnesium ribbon. So we can write magnesium. This magnesium is reacting with burnt in air with burnt in oxygen. So air also sometimes they can ask. So magnesium oxygen. What we can get? Magnesium oxide. Magnesium oxide. Magnesium oxide. See here, this is called which equation, ma? Word equation. What we call this? Word equation. Word equation. So here just to observe, these are the left hand side. These are right hand side, which are present on left hand side, those are called reactants. Those are called what? Reactants. So which are present right hand side, those are called products. So in between, this arrow mark is present towards the product right handed side. Arrow mark is present towards arrow, which one? Right hand side. So this indicates this arrow mark can indicate the new product is formed. So some chemical reaction takes place. Arrow mark tells chemical reaction takes place here. So here means it is converting. So magnesium and oxygen are converting a magnesium oxide. It's okay. So here magnesium oxide. So which are reactants? Magnesium and oxygen. Magnesium and oxygen are reactants, and magnesium oxide is a product. So here magnesium product means what? During the chemical reaction, which is formed a new substance, that is called as a product. During this chemical reaction, which is formed a new substance, that is called as a product. So okay, then how to write chemical equation? Okay, we know chemical reaction can explain statement form, that is difficult. At the same time, we can saw the word equation. Words like this we can write. Then we will discuss in this part writing a chemical equation. What are the steps involved in this writing chemical equation? So some steps we can follow to write the chemical equations. Which chemical equation? Balanced chemical equations. Which chemical equations? Balanced chemical equations we can observe. So next see, we'll discuss the topic. This is 1.1. Writing a chemical equation. With that, writing a chemical equation. Writing a chemical equation. Writing a chemical equation. So here, chemical equations can be made more concise and useful if we are chemical formulae. We are known, we use chemical formulae instead of words. So more concise. Even if you are using the chemical formula instead of words. So just you can see a chemical equation represents a chemical reaction represents a chemical equation. So here what is saying? Chemical equation. Chemical equation is represents. What it represents? Chemical reaction. Chemical reaction. Okay. So chemical equation is representing the chemical reaction. Chemical reaction. So okay. So just you observe here. Whatever activity 1 only we can consider it. So based on that, so we can discuss. So magnesium ribbon bonds in presence of oxygen to form magnesium oxide. That only I am taking here. Magnesium, it is reacting with oxygen. It is reacting with oxygen to form magnesium oxide. Magnesium oxide. So already we know these are the reactants. These are the reactants. These are the products. Again I am telling. So this is the left hand side substances. These are the right hand side substances. Right hand side substances. So this equation is called as a word equation. What we call this equation, ma? Word equation. So just we can mention the words, the formation of words, whatever present in the statement, that words we are taking. So, okay. So then, so if you know the formula, then it will be easy. Easily we can write the, which one? The equation. So magnesium means, what is the symbol of magnesium? Mg. Oxygen. So here we take oxygen means, generally you are thinking O, but don't take O. It is a diatomic molecule. Oxygen is a diatomic molecule. That is why you should write O2. Then magnesium oxide means MgO. MgO. So this equation is called as a skeleton equation. Skeleton equation or unbalanced equation. Unbalanced equation. Unbalanced equation. So what we call this equation, ma? Skeleton equation or unbalanced equation. Unbalanced equation. So okay. So next, so like that we can write the chemical equation. So after that, Balanced chemical equations. What is the topic? Balanced chemical equations. Balanced chemical equations. So now we can recall the law of conservation of mass. Now we can recall the law of conservation of mass. So it was studied in the 9th class. Was studied in the 9th class, law of conservation of mass. It's okay. It was studied in the 9th class. So according to law of conservation, what is the law of conservation? Law of conservation of mass can explain means. So mass can neither be created. Mass can neither be created. Neither be created. Mass can neither be created nor destroyed. This is the statement for law of conservation of mass. Mass can neither be created nor destroyed. That means mass we can't create, at the same time we cannot destroy. Means, so whatever involved in the chemical reaction, so same number of atoms are present both sides. So weight does not change. Same weight when present. Reactants and products, same size is present. Same weight is present. Same number of atoms are present. Same number of atoms are present. So okay, so here total mass of the reactants equal to total mass of the reactants. Total mass of the reactants is equal to total mass of the products. Total mass of the products. Total mass of the product. According to what? This law of conservation of mass. Law of conservation of mass. So where? In chemical reaction. Where it is? In chemical reaction. So here the number of atoms of each element remains the same before and after the chemical reaction. Before and after, what happens? How many number of atoms present? Same number of atoms are present in the product side also. Reactant side, product side, same number of atoms of elements present. So okay. Hence, we need balance Skeleton equation. We need to balance Skeleton equation by using this law of conservation of mass. So now we can discuss step by step how we can balance the equation. How we can balance the chemical equation. How we can balance the chemical equation. How to balance chemical equation. See, so now here I am taking activity 1.3. Which activity I am taking here? Activity 1.3. Activity 1.3. So in that it is represented as what equation already we know now? Zinc. Zinc is reacting with sulfuric acid. Zinc is reacting with sulfuric acid to form zinc sulfate. To form zinc sulfate and hydrogen gas. So here one thing you remember, ma. So more than one reactant or product, whatever it may be. So we can keep plus symbol. You can keep the plus symbol. So here two reactants. So these two reactants are connecting with this plus symbol. Plus the symbol. Here also two products are there. It is connected with the plus. So plus. So reactants and products between which what we can keep arrow mark towards the product. So this is what, which equation this is? Word equation. So then this word equation is writing unbalanced equation. So unbalanced equation means what we can write? You should write the formula only. No need to balance here. So what is the zinc formula here? Zinc, Zn. And sulfuric acid formula? H2SO4. Zinc. So if these two reactants are there, that's why I am separating with the plus symbol. So then, what are the products of zinc sulfate? What is the formula of zinc sulfate? Zinc Zn-SO4. And what is the another one? Hydrogen gas. Hydrogen gas means you can write H2. Why? Because already I said oxygen. In case of oxygen, I discussed it. So oxygen is a diatomic molecule. At the same time, hydrogen also diatomic molecule. That time you can keep H2. When you are balancing the equation, hydrogen means you can write H2. Okay. H means element. It is a molecule. Okay. Hydrogen molecule. Here is a gas. Hydrogen gas means you can write the symbol H. So, okay. Then you can see how many kinds of atoms are there. How many types of atoms are there. Just you can write here. The first one is zinc is there. Then hydrogen is there. Then sulfur is there. Then oxygen is there. So here reactant side. This is product side. So just you observe the equation. Reactant side, product side. Number of atoms you can count. How many zinc atoms are there? Reactant side only 1. And product side how many? 1. And hydrogens. How many hydrogens are here? 2 hydrogens. This side how many hydrogens? 2 hydrogens. And how many sulfurs are there? Only 1 sulfur. Here how many sulfurs are there? Only 1 sulfur. How many oxygens are there? 4 oxygen atoms. Here how many oxygens? 4 oxygen atoms. So you can remember, ma. So subscript number indicates the number of atoms. The subscript indicates the number of atoms. The coefficient number means before the formula we can write whatever you can write the number, that is a coefficient number. Means for example I keep 2Zn. 2Zn means 2 zinc molecules are there. Okay. So at the same time here 2H2SO4 is there. For example I can keep. In that 2H2 2 molecules of hydrogen sulfuric acid. 2 molecules of sulfuric acid. In this 2 molecules of sulfuric acid, how many hydrogens are means just 2 into multiply this 2. Subscript into coefficient number. So we can get the total number of atoms. Okay, this is subscript. This is a coefficient number. This when we are multiplying this, we can get the how many number of atoms are present. For example, here subscript 1 is nothing is there means 1 is present. So 1 into 2, 2 sulfurs are there. 4. How many oxygen atoms? 4. So in this 2 molecules, how many oxygen atoms? 8 atoms are 4 into 2. Like. So okay, I hope you understood. So okay, now we can say, is this equation is balanced or not? According to this, so this side one hydrogen, zinc, this side zinc, this side two hydrogens, here two hydrogens, here one sulfur atom, here one sulfur atom, here four. So the equation is balanced. The equation is balanced. Why? Because according to law of conservation of mass, what reactants number of atoms present at reactant side and the number of atoms present at product side both are in equal. So according to that, here both sides are equal. So this equation is balanced. This equation is balanced. So next we can see one more equation. One more equation. So here a statement they given balance the following chemical equation. Balance the following chemical equation. So directly you can give formula with a skeleton equation he given. So what is that? Iron is reacting with water to form ferric oxide Fe3O4 and liberating which gas? Hydrogen gas. So this equation is given. So previous equation directly it is balanced. So okay. So here step by step we can balance. So some steps are involved to balance the chemical equations. Directly. So how we can balance this chemical equation means we are using heat and trial method. Heat and trial method we can use to balance the chemical equations. So let us see step 1. What is that? Step 1. So what happens here? Step 1 means balance a chemical equation. First draw boxes around each formula. So whatever written formula now, I am writing here Fe plus H2O. I am giving space. Okay, Fe3O4 ferric oxide plus H2. What is saying? Keep boxes to the formula. Keep boxes for formula. Can keep box for the formula. So I am using different color. So it's good. Red. Iron. Yes, I am keeping one formula. Here box. Like that you can keep the boxes. Before going to balance, we can keep the boxes to the this whatever molecules, whatever substances present formulas. Okay, this is the first step. Next, second step. Second step 2. So I hope you understood step 1. Very simple step 1. What is the step 1? Just you can keep the boxes further to the formulas. Whatever formulas we written, just you can put boxes. And step 2, list the number of atoms of different elements present in the unbalanced equation. Is it balanced? No, it is unbalanced equation. So here what you can do, list out the how many types of atoms are there. So list the number of atoms of elements. Number of atoms of elements. Number of atoms of elements. Okay. So how many kinds of, how many types of atoms, how many kinds of atoms are there? Just to listen. Iron, then hydrogen, then oxygen. So this is reactant side, here product. Here product side. Just you can count. How many iron atoms? One iron atom. How many hydrogens? Two hydrogen. Subscript number indicates the number of atoms. How many oxygens? One oxygen. This side, how many iron atoms? Three iron atoms. Subscript number indicates the number of atoms. So how many hydrogens? Two hydrogens. How many oxygens? Four oxygens. So in this unbalanced equation or in this curtain equation, which element of atoms of element is more? That is oxygen. So oxygen is more number of atoms are present. Four number. Oxygen how many? Four number of atoms are present. So I hope step 2 also understood. And next we are going to step 3. Step 3. Step 3. So in this step 3, start the balancing with the compound that contains maximum number of atoms. So where we have to start to balance the equation? Which atom have maximum number? So in the given equation, which one having more number? Oxygen having more number of atoms. That's why we have to start with oxygen. That's why we have to start with oxygen to balancing this equation. So let's start. So, okay. So now we can write. So first we can select the Fe3O4. No, we can choose Fe3O4. So I am writing atoms of oxygens. Atoms of oxygen. Atoms of oxygen. Initial means starting, and to balance how many are there, how we can balance, which one? Atoms of oxygens. So just first in reactants you can see, in reactants, in products, in products. So reactants means, so here a water molecule only present, one oxygen is present in where? One molecule of water. Here it contains only one atom of oxygen. At the same time products, ferric oxide, 4 oxygen atoms are present in where? In Fe3O4. Fe3 in Fe3O4 ferric oxide. How many are there? 4 oxygen atoms are there. So these are the initial starting. How we can balance? Here only 4 atoms are there. Here 1 atom is there. So how we can balance? So why here 4 only? Here how we can get the 4 this side also? So 1 into 4. So this 1 is multiplying with 4. Finally we are getting 4. So we can write 4H2O. 4H2O. Right. So after this equation is the iron plus H2O gives rise to Fe3O4 plus H2. In starting what we discussed, balancing equation, we should keep the boxes for what? Formulae. Means whatever present inside the box, we can't change when we are balancing the equation. That point you should keep in our mind. Why we are keeping the boxes? So when we are balancing time, we never change the whatever present in the inside the box. So only outside only we can change. So now what we can write? Here oxygen 4. So you should keep 4. Means 4 into 1 4 oxygen atoms. Here 4 oxygen atoms. So oxygens are balanced or not? So which is more, that you can balance first. Which atoms are more, that you can balance the first. Okay, it is which step now? Step 3. Next going to step 4. Step 4. Step 4. Wait. So first we are balancing the oxygens, which is more, that you can balance. Next step 4. Step 4. So in that step 4, what are the remaining still not balanced? Iron is not balanced. At the same time, hydrogen also not balanced. So these two are not balanced. It's okay. So in these two, anyone you can pick to balance. So exactly you can take iron, exactly you can take hydrogen, no. So anyone you can pick the balance. So let us balance the hydrogen atoms. What you can balance? Balance hydrogen atoms. Balance which atoms, ma? Hydrogen atoms. So atoms of hydrogen, atoms of hydrogen, atoms of hydrogen in reactants, and in products, in products. So, okay. So atoms of hydrogen, first here what you can write? Initial to be balanced. So initial reactants, how many hydrogen atoms are there? 8 hydrogen atoms are there. Where these 8 hydrogen atoms? In 4 molecules of water. 4 molecules of water, how many? 2 into 4? 8 hydrogen atoms are there. And products, 2 hydrogen atoms are present. Where? In hydrogen. So now how we can balance? Here 8, but here 2 only. So 2 into 4, then we can get the 8. So the equation would be the equation. Already we balanced which atoms? Oxygen atoms balanced. So now hydrogen is balanced. The equation would be what? Iron plus H2O gives rise to Fe3O for ferric oxide plus hydrogen. So then what we can write? We can keep the boxes to understand purpose. 1, 2, 3, 4. It's okay. So already what we balanced? So what we balanced before? Oxygen's balanced, no? Here 4 I kept. So now hydrogen's balanced. Hydrogens here 8 hydrogens. Here what will come? 4H2. 4H2. So okay, 4H2. So now here 8, here 8, here oxygens 4, oxygens 4. So what is the remaining? What is the remaining? Iron atoms. So remaining which is present? Iron. So now we can check. So because here 3 product side, how many are there? 3. Simply easily you can balance. Here 3 is there. Here just you can keep 3. So these numbers are there now. 3, 4. Here nothing is there means 1. Here 4. These are called coefficient numbers. These are called what, ma? These are called coefficient numbers. Coefficient numbers. Before the formula, whatever we can write, whatever number we can write, that number is called coefficient number. It can represent the number of molecules. How many HCl molecules, how many oxygen molecules, like that. It's okay. So finally we can get the equation. So here I explained here only. So hydrogen atoms as well as iron also both I balanced here only. So okay, ma. So now we can write it. This is the balanced chemical equation. So whether it is balanced or not, how we can check? Already we know that method. First equation we did know. Same method we can do. So let you see. So how many atoms? Here reactants you can write. Reactants this side, products, here element. How many elements are there? Iron is there, then hydrogen is there, then oxygen. So reactant side you can check. Reactant side. So how many iron atoms are there? 3. How many hydrogens are there? Here 2. 2 into 4, 8. How many oxygens are there? 4. Then product side. How many iron atoms? 3. And how many hydrogens? 2 into 4, 8. How many oxygens? 4. So means both side. Here 3, here 3, here 4, 8, here 8. So according to law of conservation of mass, number of atoms of reactant side, number of atoms of product side, both are same. So this equation is a balanced equation. This equation is a balanced equation. What we call this equation, ma? Balanced equation. Balanced equation. Okay. So next. Okay. So here, so what is this method name is called? Which method, amma? Heat and trial method. Heat and trial method. Heat and trial method. Here, my question is it equation is informative or not? Complete informative or not? No. Just iron, water. This it's not informative. When equation is in chemical reaction, chemical equation is more informative. When chemical equation is more informative. So just you are writing symbols and balance the number of atoms. That's all. But when it will be more informative, means more informative means we should write states of matter. We should write the states of matter. So let's see. When it is more informative, first you can write physical state of the matter. Physical state the matter. Physical state of the matter. So already you studied in the 9th class. How many states of matter is there? 3 states of matter is there mainly. What are that? Solid, liquid, gas. So, okay, if the substance is solid, you can use the symbol small s in brackets. Liquid means you can keep small l. Gas means you can keep c. Or sometimes you can use upward arrow mark. If any solid substance is formed in the chemical reaction, that time you can use a downward arrow mark also. Here upward arrow mark here. Gas means upward arrow mark. It's a precipitate. Already we discussed. No, precipitate means you can use downward arrow mark. Then aqueous. What is that? Aqueous. So what is the meaning of aqueous? Aqueous means any substance, any substance, any substance is dissolved in water, is dissolved in water, is called aqueous solution. Is called aqueous solution. So aqueous means we can use the symbol AQ. So instead of water, aqua means water, no? Aqueous solution. Any substance is dissolved in the water, that is called as a aqueous solution. If it is in any substance is dissolved in alcohol. Alcohol means we can write the symbol alcohol solution means alcohol means we can write AL. AL. So these symbols we can use to represent the physical state of the whatever involved in the chemical reaction. Is that clear? So okay. Next one. So not only this physical state and somewhat information. So physical state we got. So next, so above equation we are writing. So for our above equation, what is that? 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Yes, this is the equation. So iron is means what? Solid, no? That's why you can keep small s. And water, it is a liquid. Liquid. Generally, we are thinking liquid, but it is not here. In this case, it's not a liquid. Already it came in 8th class. It is a vaporized. The water in the vapor state means gaseous form. So that's why we can keep small g. Here, yes. Here, gas. So this now we can see this equation is more informative when compared with the previous equation. We can compare with the previous equation. So here we are all mentioned these physical states. So some more information also needed here. So sometimes the reaction conditions also we can mention. Sometimes what we can mention, ma? Sometimes we can mention reaction conditions. Reaction conditions also mention. Reaction conditions. So what are the reaction conditions? Like temperature, pressure, catalyst, etc. Okay, temperature, pressure, catalyst. So these reaction conditions also we can mention sometimes, not every time. For example, you can see examples. CO carbon monoxide plus hydrogen gas gives rise to methyl alcohol. So here carbon monoxide is a gas and hydrogen also gas. Methyl alcohol is liquid. But here condition is pressure is there. This pressure is mentioned right on the above or below the arrow mark. So this whatever conditions is there, no? These conditions we can mention above or below the arrow mark. Above or below the arrow mark. At the same time, one more example. 6CO2 plus 12H2O gives rise to C6H12O6 plus 6O2 plus 6H2O. So here controversial equation, some biology students different. So here also just remember. So this is photosynthesis equation. So carbon dioxide it will get from the atmosphere and water is a liquid. Here glucose is a liquid form. Liquid form means so why it's not a liquid form, but we can't write liquid. Why we can't liquid? This glucose is present in the inside, present in the plant in the form of liquid. So any substance is dissolved in water, what we call aqueous. So you can write aqueous. So here oxygen gas, here water also gas. Why? Because it is vapor form, it will come. But in different in textbook they given this is a textbook what is given. So this is CO2 is aqueous, right? Written, and water it is a liquid written. So has to be written, and glucose aqueous written, and oxygen also aqueous, but water in form of liquid. So nobody will ask. If you ask means whatever they given in the textbook you can write it. It's okay. Why? Because main important is textbook, no? So we can follow the textbook, NCERT textbook. So this is about the balanced chemical how to balance the chemical equations. It's okay. How to balance the chemical equations. Some in-text questions also given. What they given? In-text questions. So textual questions they given. We will discuss 3 questions. I think 3 questions are given. So these 3 questions also we will discuss. Okay. These 3 questions. So in-text questions. In-text questions. So the first question is which color is better to write? Yellow. It's okay. I will write with white color only. Why should a magnesium ribbon? Why should a magnesium ribbon be cleaned before burning air? Be cleaned before burning in air. This is the question. Already we saw this activity 1.1 magnesium first activity only, textbook first activity only. Generally what we know, what I said, metals react with oxygen to form metal oxide. So in case of magnesium, the magnesium is reacting with oxygen to form MgO, magnesium oxide. balanced. This is solid, gas, this is solid. So thin layer formed on the surface of the magnesium ribbon. So we are by removing sandpaper, which one? This magnesium oxide. If in case this magnesium oxide is present, it does not burn. We can't get the white color powder. Why? Because it is already oxidized. That's why further oxidation does not takes place. Does not takes place. Okay. Because of this reason, we can clean the surface of the magnesium ribbon before burning in the air. I hope you understood. So already oxidation, this magnesium layer is formed. So means that is oxidized. Once oxidized means further oxidation does not take place. Further oxidation does not take place. This is the reason to remove one whatever present on the magnesium ribbon, the layer will remove. This is the reason. So without this, not any reasons, simply already oxidized. So once oxidized means further oxidation does not take place. Further oxidation does not take place. This is the answer. So try to understand. Understand the questions, how they ask. So in text questions only first I will discuss. Later I will discuss NCERT questions, objective questions, NCERT exemplar questions, everything I will discuss with you. Okay, so next question is question number 2. Question number 2. Write the balanced equation for the following chemical reactions. Write the balanced equation. Write the question. Write the balanced equation for the balanced equation for the following chemical reactions. Following chemical reactions. So, okay. So first one is just he given word equations. Very first one, hydrogen plus chlorine gives rise to hydrogen chloride. So I will tell later, as session basis I will discuss what is the difference between hydrogen chloride and hydrochloric acid. Later we will discuss. So here hydrogen means, I said clearly, it is a diatomic molecule, already learned in the 9th class. So hydrogen means what we can write? H2 only. Then chlorine means Cl2 only. So then what hydrogen chloride formula? HCl. Just you can observe here 2 hydrogens, here only 1 hydrogen. Here 2 chlorines, here only 1 chlorine. So if we keep 2, everything is balanced or not? If we keep 2 here, everything is balanced. So this is a gas, this is a gas, this is also gas. This is also gas. So the next, this is already balanced. Here 2 hydrogens are there, 2 chlorines are there. Here 2 hydrogens are there, 2 chlorines are there. Any doubt here? Equation 1? Nothing. It's okay. Next, 2. What is that? Second one. So what is that? Barium chloride plus aluminum sulfate so no space, that's why I'm writing here continuation, gives rise to barium sulfate plus aluminum chloride. Okay. So first we should know the formulas, then only we can balance the equations. Otherwise, it's a very difficult to balance the chemical equations. Everyone should keep in your mind, you should learn the formula. So if it is possible, I will discuss one class how to write the formulas. Okay, barium chloride means BaCl2, barium chloride plus aluminum sulfate, Al2SO4 taken 3 times. So gives rise to barium sulfate BaSO4 plus aluminum chloride AlCl3. See, first which one is more? So here sulfates are more. Just observe, here sulfates are more, 3 sulfates. So we can balance the first one is sulfates. So how many are there here? 3 is there, you can keep 3 here. Sulfates balance, SO4s are balanced or not balanced? Then remaining, how many bariums? 3 bariums, so you can keep 3. Bariums are balanced or not? Bariums also balanced. How many chlorines are there? 6. 2 into 3, 6. Here keep 2. So 3 into 2, 6. Chlorines are also balanced. How many aluminiums? 2 aluminiums. So everything is balanced or not? So this side, barium, aluminium. You can write individual. I am writing SO4s only. It's okay. And barium, aluminum, chlorines also there. Here this side, 3 bariums. How many aluminiums in this side? 2 aluminiums. How many sulfates? 3. How many chlorines? 6. Here this side, same, 3 bariums, 2 aluminiums, 3 sulfates and 6 chlorines. So equation is balanced. So why I am taking here sulfate means this is single ion. So here also ion, sulfate ion, here also sulfate. That's why I am taking this sulfate ion. It's okay. Is that clear? Any doubt in that? I hope. No doubt. Thinking no doubt. Okay. Next. Going to third question. Sodium plus water. Gives rise to sodium hydroxide, plus hydrogen. No space, that's why I'm writing hydrogen. So first what we can do, we can write the formula of the given compounds. Sodium, it is a monoatomic. Why? Because maximum metals are monoatomic one. So you can write sodium means Na, and water formula H2O, and sodium hydroxide. What is the formula? NaOH. And what about hydrogen means? Already I said clearly H2. So first, which one is more? Here hydrogen 2, here hydrogen 3. Where 3 hydrogen atoms are there. So we can balance the hydrogens. So if we keep 2, How many hydrogens? 4. 2 into 2, 1, 2, 2, the 4. So here 2 only. So 2 into 2, 4. Here how many sodium atoms? 2 sodium atoms. Here one, only 1. So you can multiply with. So next, what is it? This is solid. This is liquid. This is aqueous. This is gas. This is a gas. So equation is balanced. Equation is balanced. Okay, this is about second question. The 3 sub questions they given. So this is based on they given skeleton equation. So we are writing balanced chemical equations. So next question number 3. Next, which question one? Question number 3. Question number 3. So what is given? Write balanced chemical equation. Write balanced chemical equation. Balanced chemical equation. Balanced chemical equation with state symbols. With state symbols. With the state symbols for the following reactions. For the following reactions. So very first one. Here they are given statements. First statement. Solutions of barium chloride. Solutions of barium chloride. Barium chloride. Solutions of barium chloride and sodium sulfate. And sodium sulfate where in water react to give insoluble barium sulfate. Insoluble barium sulfate. Insoluble barium sulfate. And the solution of sodium chloride. And the solution of sodium chloride. Sodium chloride. This is the statement. This is the statement. So what they are asking? Write symbols, including physical states of symbols. They ask. Okay. So first you can write. So which are reacting? Barium chloride and sodium sulfate. So where water. React to give which one? Insoluble barium sulfate and aqueous solution of sodium chloride. So first we can write the formulas. We can write the formulas. So okay. Barium chloride means what? So directly no need. Direct formula I am writing. BaCl2 and sodium sulfate. Sodium sulfate means Na2SO4 gives rise to barium sulfate BaSO4 plus NaCl. So here which is more? Sulfate, okay, common. So sodium and chlorine both are equal. So that's why I'm starting with sodium metals. So Na2SO4 means just I keep 2. Yes, 2 sodiums are balanced. How many chlorines? 2 chlorines. Here 2 chlorines. How many bariums? Barium. So means remaining same. So barium chloride is here, they mention in water. In water means what we can call, right? Aqueous. This is also aqueous. Here said insoluble. Barium sulfate. Insoluble means what we can write? Solid. The aqueous solution means H. So this is the answer for this question. So okay. So first we are writing the formulas. Then we can balance. After we can write the physical states. Someone is insoluble means that is called as a precipitate. So precipitate means what we can write? Yes, or sometimes we can write downward arrow mark. You can write a downward arrow mark. So okay. So this is the first question. So next last question is there in this chemical equations. I will discuss and conclude these chemical equations. So okay. Then second one is sodium hydroxide solution. Sodium hydroxide solution. Sodium hydroxide solution means I have mentioned clearly in water. I am writing simply in water. Reacts with hydrochloric acid. Reacts with hydrochloric acid. Hydrochloric acid solution. Hydrochloric acid solution. This is also in water. To produce sodium chloride. To produce sodium chloride solution and water. So here just you see sodium hydroxide reacts with hydrochloric acid to produce sodium chloride and water. So first we can write what we can write? Formulas. Sodium hydroxide NaOH, hydrochloric acid HCl, sodium chloride NaCl plus water. So solutions mentioned water. So that's why we can write AQ. Here what AQ. Here AQ. So in a sodium chloride solution AQ. So this is liquid. So here just you observe everything is balanced. So all are 1 1 1. So everything is balanced. Okay, nothing is more. So okay, this is about topic chemical equations. In this topic we discussed some physical activities. They can explain the about chemical changes. Later we discussed how to balance the chemical equations, how we can make the chemical equation more informative, and how we can balance the chemical equations. Everything we discussed. So in coming classes, next topic, types of reactions I will discuss. Next topic is types of reactions. That is also very important for board exams. So please subscribe my channel and share this video to your friends. It is very helpful to me. Thank you.